in this lesson, we're going to use square roots to help solve equations. Previously, in section 10.3, we used graphing to help solve equations, and we saw that the zeros of the equation, or where the function and its graph cross the x-axis, were the solutions. So we saw where it crossed the x-axis, we circle those numbers, and those are our solutions. Today we're going to start one of a handful of methods for solving these when we don't have to graph, or when maybe graphing is more difficult or something we just don't have the time or ability to do. We'll start with a quick warm-up. We are going to use square roots, so just maybe we come up with some square roots here real quick. Let's see. Negative square root of 49, that's the same as opposite of 7, square root of 49. What times itself is 49 is 7. Square root of 200, we can use a calculator to come up with an answer for that. On a scientific calculator, we could do square root, which is second of the square button, second and square root of 200, close parenthesis, hit enter, and it's approximately 14.14. Plus or minus square root of 121. 121 is a perfect square. 11 times itself is 121. So this is plus or minus 11. We're going to try to solve quadratic equations using square roots today. However, we can't just use these all the time. So we need to know like when we can use them, when we can't. So we'll start there. When can I use this? I'm allowed to use this when there is no linear term, which is the same as, i.e., no x term, only x squared and constant. So we can't use this all the time. We can only use it when there's only an x squared or something squared. We can't use it if there's more than just something being squared. We'll use other methods that we'll learn later on. We'll learn later in the unit here to help when we do have those x terms. So we're going to see examples of today where there's where we've either done some manipulation to avoid having the x term or just didn't exist in the first place. Okay, so if I do have something that's squared, what can I do? Well, just use a square root. We'll do the following. First, we're going to isolate, means get by itself, what is being squared. So I need to first figure out what in the heck in my problem is being squared. Then I'm going to get that thing by itself. Generally involves getting like x squared all alone, or like a set of parentheses that are being squared all alone. I'm going to use, or how about find the square root of both sides. Remember, there's going to be a positive and negative answer to this step. And then 3, finish solving both equations if necessary. And we'll see this this last part will come up quite a bit, especially if we have, this comes up a lot if you have like a group of parentheses being squared, like x minus 2 squared equals 5. This will have two equations that we'll have to solve, and we'll see how to do that later on. But this will generally happen if you have a set of parentheses being squared. Anyways, let's look at some examples. So the three on the front side of our sheet here say solve the equation c squared minus 25 equals 0. So I want to first, I know I can use the square root because there's no linear term. There's just a variable squared. There's no variable of the first power. So I'm going to isolate what's being squared. So I'm going to try to get the c squared by itself. In this case, I see if I add 25 to both sides, then I get c squared equals 25. Okay, so once I've got what's being squared by itself, then I find the square root of both sides. So I find the square root of c squared and the square root of 25, and that yields me two answers. C could be positive 5, or C could be negative 5. Note there are two answers, because both 5 times itself is 25, and also negative 5 times itself is 25. We'll commonly write, if these two numbers are the same, just opposite signs, we'll commonly write this as plus or minus 5. Okay, but this really is two answers. Not one, it's two. It comes from positive 5 or negative 5. Okay, let's try again. Well, we subtract 12 from both sides. Get 5w squared equals negative 20. Divide by 5 to get the w squared by itself, because we're trying to get the w squared by itself. And we get w squared is equal to negative 20 divided by 5, which is negative 4. Okay. Take a square root of both sides. So w is equal to, and now we're at a problem, because we're trying to find the square root of a negative number. So this is saying what times itself is negative 4. Your only real choices are like 2 or like negative 2 in terms of the real numbers. 2 times 2 is positive 4. Negative 2 times negative 2 is also positive 4. Since no real number times itself can be a negative, there are no solutions. No number times itself is a negative number. So you could take a shortcut here and then realize that if you get what's being squared and that's equal to a negative number, you might as well just stop, because there are no possible real number that gives a solution. Okay, so how about we try again? Minus 11, 2x squared equals 0. Get what's being squared by itself, so divide by 2. 0 divided by 2 is still 0. Okay, what's being squared is by itself, so I find the square root. What times itself is 0? 0. So you could think of this as like positive 0 or negative 0. This doesn't make sense. Negative 0 is just positive and negative 0 are the same. So this is a case where there's one answer or one solution. So we had no solutions, one solution, and two solutions in this case of our quadratics. Okay, let's look at some more examples, and those will be on the back side. Okay, I look at my first example and I see, oh, there's only an x squared term, so I don't have to worry about. I can use this idea. I'm going to try to get the x squared by itself, so I divide by what's in front of it. And rather than using a decimal, making this answer really hard on myself, I'm going to leave this as an improper fraction. 16 divided by 25. I chose to do that because I'm astute enough and I've been looking for patterns like I've been asking you all year, and I note that 16 and 25 are both perfect squares. So when I find the square root of both sides of this equation, I get x equals positive square root of 16 is 4, and the square root of 25 is 5. Or I get negative 4 over 5. I'm getting it because of this nice property of radicals. Okay, there's not really much more for me to do, so I'm done. Or maybe more shortly, plus or minus 4 over 5, if you so choose. Okay, I do it again. M squared is 100 over 9. I use a square root. I get m is equal to positive 10 over 3, negative 10 over 3. And I'll abbreviate this with plus or minus 10 over 3. One more time for good measure, I subtract 64. 49b squared equals 64. Divide by 49. B squared equals minus 64. Square root of minus 64 over 49. No, I'm getting ahead of myself. I look to take the square root, but then I stop myself and I say, well, what's being squared is equal to a fraction that, although it looks like it has nice numbers, has one major problem. It's negative. So since I'm asking anything, I'm asking for what times itself is a negative number. It ain't possible. So since my squared is equal to a negative number, whether it be a nice fraction or not, it's equal to a negative number. I can't take can't find a negative square root. Okay, up to this point we've had nice perfect squares. So the last set of examples here, we're going to have non-perfect squares. So we can handle those. We're just going to likely need, we'll just have to use a calculator to get a nice rounded answer. But the process stays the same. So x squared plus 4 equals 14. I still am going to isolate what's being squared. I'm still going to try to find out what makes x squared equal to 10. I've gotten what's being squared isolated, so now I'll use a square root, and I'll say x is equal to plus the square root of 10, or x is equal to minus the square root of 10. Using a calculator, I can hopefully come up with an approximation. So I could say square root of 10. So x is approximately positive 3.16, or x is approximately negative 3.16, or maybe more succinctly, x is approximately plus or minus 3.16. Same game. Let's add 1. 3k squared equals 1. Divide by 3. K squared is equal to 1/3. So I'll use a square root, and I'll get k is equal to positive square root of 1/3, or k is equal to minus square root of 1/3. Okay. If I want to type that in to my calculator, I'll do square root 1 divided by 3, close the parenthesis, hit enter, and k is approximately positive 0.57, nearest hundredth would be better, 0.58, or k is equal to minus 0.58. Note nearest hundredth, so second decimal spot. Or since these are the same, how about k is approximately plus or minus 0.58. For completeness, how about we add 7 to both sides and get 2p squared equals 9, divided by 2, p squared equals 9/2. Find a square root, and I have p is equal to square root of 9/2, or positive, or p is equal to negative square root of 9/2. Type square root of 9 divided by 2, close parenthesis, hit enter. P is equal to positive 2.12, or approximately, more appropriately, or P is approximately negative 2.12. P is approximately equal to plus or minus 2.12. The last 3 examples are where life gets a little more complicated. Note that now we have a group that's being squared. And that's all. The only thing we have is a group being squared, other than like something multiplied to. We don't have like another x outside of this. So we still can use square root because we can just find the square root of this big thing, but we got to get it by itself. These are examples, though, where that last step, where I said we're going to have to solve another equation if possible or two, is going to come in handy, and I'll show you how. So first I want to get what's being squared by itself. What's being squared is this group of parentheses. So I need to get this thing by itself. So I want to undo everything else. So I have a 2 times that group. I want to divide both sides by 2 to get rid of the 2 on the outside. So this is really x minus 2 squared equals 9. Now I've got what's being squared by itself. So like we did before, we'll find a square root, both sides. And like before, I'll take whatever the square root is, x minus 2, that's equal to positive square root of 9, or x minus 2 is equal to the minus square root of 9, which is 3. I'm not done, though, because I still haven't got x by itself. So I still have to undo that thing that was inside the parentheses for each of these. So I still have to solve each of these little one-step equations. So I add 2 to this one. So in this first case, x is 5. Or in this case, negative 3 plus 2 is negative 1. Okay, notice this is not just plus or minus some number. How do I know ahead of time it wasn't going to be plus or minus? Because there was the group inside. These are two very distinct answers. I better have both written down. This is the most common I'll see it a lot. We'll take the square root and we'll have someone will solve this and say this is plus or minus 5 or plus or minus negative 1. If you follow the procedure and we note that just whatever was inside, it goes here, and solve, you'll be okay. But if you take shortcuts or do something other crazy, life won't be quite as nice. Okay. Let's try this guy. So I need to get what's being squared, which is this group by itself. So I divide both sides by 4. And get that q minus 3 squared is equal to 7. Okay, so now I find a square root, and I get that q minus 3 is equal to the positive square root of 7, or q minus 3 is equal to the negative square root of 7. Using my calculator, find that the square root of 7 is approximately 2.65, or q minus 3 is approximately minus 2.65. Now add 3 to both of these equations, and I'll find that q is approximately 5.65, or q is approximately 0.35. Something to note, both of these answers are positive, so we didn't even get a positive or a negative. These answers both are positive. So keep that in mind. Sometimes you get 2 positive answers. I'm willing to bet sometimes you get 2 negative answers, which I think we're going to see in just a minute here. Okay, last example, let's divide both sides by 3 to get the t plus 5 squared by itself. So I'm seeing t plus 5 squared is 8. Use a square root and get t plus 5 is equal to positive root 8, or, well, let's go down here. T plus 5 equals minus square root of 8. So square root of 8 is approximately 2.83 plus or minus there, subtract 5, t is equal to minus 2.17, or t is equal to minus 7.85. Two solutions. These answers look wildly different than what we had before. They're not just plus and minus, but how we got there is still the same. Only at the end here, since we had a binomial being squared, we had to solve a couple little one-step equations. How to solve them is nothing more than you've done in the past. Sometimes you might need to take a calculator, turn the square root into a decimal, get a good approximation, but that's not the end of the world. But the key here is that we do still end up getting two different answers. And in this case, they're not just the same answer, one's plus, one's minus. We knew it was going to get two different answers because we had a binomial in here. So, in conclusion, the same rules apply. Make sure you follow them to the T. And also be aware, binomials are going to give you two different answers. If you don't have binomials, like you just have a monomial being squared, just x squared or k squared or p squared, then in the end you will get your two answers will just be plus or minus of the same number.